Myself, Shaijil J, Department of Mechanical Engineering, Malabar Polytechnic College, Kottakkal. In this session, I am going to discuss the last year question paper of the course Power Plant Engineering. The course code is 5023C. Part A, 1 mark question. Name any hydroelectric power plant located in Kerala. Pallivasal Hydroelectric Power Project, Idukki Hydroelectric Power Project, and Kuttiyadi Hydroelectric Power Project. Second question. Interpret octane number. Octane number specify quality of gasoline or petrol. Third question. Determine the difference between head race and tail race in a hydroelectric power plant. Gross head. The difference between head race and tail race is called gross head. Fourth question. Identify the function of governor in diesel power plant. The main function of the diesel governor in a diesel power plant is to maintain speed with respect to load. Fifth question. Name a high head water turbine. High head water turbine means the head is more than 250 meters, then it is called high head water turbine. An example is Pelton turbine. Sixth question. Highlight the moderator when nuclear fuel is uranium. Heavy water is used as moderator when uranium is used as a fuel. Seventh question. Identify minimum size of the reactor for a self-sustaining reaction. That is called a critical size. Eighth question. Name the reactor in which primary and secondary loop system is used. Primary and secondary loop system is used in the case of pressurized water reactor. List the basic ways of controlling thermal discharges. One is we can use artificial lake, cooling ponds, and cooling tower are the methods, the controlling methods for thermal discharge. Part B, 3 mark questions. Define calorific value of a fuel or CV of a fuel. The calorific value of or heat value of a solid or liquid fuel may be defined as the amount of heat energy given out by the complete combustion of 1 kilogram of fuel. It is expressed in terms of kilojoule per kilogram of fuel. The calorific value of gaseous fuel is, however, expressed in terms of kilojoule per meter cube at a specific temperature and pressure. That means the calorific value is the heat energy, the amount of energy, heat energy produced by the complete combustion of the unit quantity of fuel. If it is a solid or liquid fuel, then it is kilojoule per kilogram. If it is a gaseous fuel, it is kilojoule per meter cube. Second question, list the requirements of good fuel. A good fuel should have a low ignition point. It should have a high calorific value. It should freely burn with a high efficiency once it is ignited. It should not produce harmful gases. It should produce least quantity of smoke and gases. It should be economical, easy to store, and convenient to transport. Third question, classify hydroelectric power plant according to head. According to head, the hydroelectric power plants are classified into three categories. One is called high head turbine, medium head turbine, and low head turbine. High head turbine means the head is above 250 meters. An example is Pelton turbine. Medium head turbine, the head is in between 60 and 250 meters. It is called medium head turbine. An example is Francis turbine. Low head turbine, that is below 60 meters. The turbine is called low head turbine. An example is Kaplan turbine. Fourth question. List the advantages of hydroelectric power plant. Water, the working fluid is natural and available plenty. Life of plant is very low. Running cost and maintenance are very low. Highly reliable operation cost is very less. No fuel requirements, no harsh disposal problem. There is no harsh disposal in the case of hydroelectric power plant. Highly reliable and life of the plant is also very low. Fifth question. List any three safety measures observed in oil handling system. For the three is required. Here I have mentioned many. Displaying the information about oil handling, hazards and way of handling and storing. Storing the oil in a properly sealed tank either in open or in the ground. The tank should be surrounded by oil-tight bond walls to prevent the leakage. Development of skills to the worker for handling the oil in case of leakage. Filling the oil in a tank, proper inspection should be carried out to achieve the same quality as per the standards. If there are open storage tank, then the electrical equipment within the space must meet the appropriate safety standards. Sixth one, list measures to control thermal pollution. One is cooling tower. You can use cooling port, artificial lake, spray ponds are some examples for controlling the thermal pollution. Seventh one, state the function of moderator in a nuclear reactor. Moderator is used to slow down the kinetic energy of fast moving neutrons. It is because only slow moving neutrons maintain the fission chain reaction. To help distribute the neutron evenly throughout the reactor core. This ensures that all of the fuel is exposed to neutron and that the chain reaction is sustained evenly. To reflect neutrons back into the reactor core, this helps to keep the neutron in the core and prevent them from escaping. Eighth question: express greenhouse effect or define greenhouse effect. The greenhouse effect is when certain gases like greenhouse gases such as water vapor, carbon dioxide, methane, etc. in the atmosphere trap heat from the sun, keeping the earth warm and prevent it from freezing. This is natural and help support life. But when we add more of these gases through activities like burning fossil fuels, it traps even more heat, leading to global warming. Such an effect is called the greenhouse effect. Ninth one, command the methods to prevent acid rain. The only precaution that we can take against acid rain is having checked at the emissions of oxides of nitrogen and sulfur. Acid rains are mainly produced by the oxides of oxygen and sulfur, which will be reacted to the water vapor in the atmosphere or water molecules in the atmosphere and converted to nitric acid and sulfuric acid. So that will be uh, produced as a acid rain. Acid rain in harmful. Acid rain is harmful to animals, plants, and monuments. Being a responsible citizen, one should be aware of the harmful effects they cause and of the industries which give out nitrogen and sulfur compound waste unethically. 10th question, identify the purpose of control rods in nuclear reactor. Control rods are used to control the nuclear chain reaction. Control rods control the chain reaction by absorbing neutron. The chain reaction can be controlled by absorbing the amount of number of neutrons. Control rods are usually made up of cadmium and boron. There are two main types of control rods. One is called boron rods and other is cadmium rods. Boron is a very effective neutron absorber, so boron rods are often used to control the reaction. Cadmium rods is also good neutron absorber, but it is not as effective as boron. Part C, 7 mark question. First one, list the merit and demerit of liquid fuel over solid fuel. The first one is the merit and second is the demerits. The merits of the liquid fuel are higher calorific value. Second, lower storage capacity is required compared to solid fuel, liquid fuel having a lower storage capacity. Better economy in handling, better control of consumption by using valves. We can adjust the valve to supply the fuel and cut off. That is not easy in the case of solid fuel. Better cleanliness and freedom from dust. The case of solid fuel, there will be great amount of ash will be there that will be creating so many problem as like dust. Practically no ashes, non-deterioration in storage. We can use for long period of time. Higher efficiency. The demerits are the cost is very higher for the liquid fuel. Greater risk of fire. The chance of fire quickly it may be ignited. Costly containers are required for storage and transport. For storing the liquid fuel and transportation is much costly. Next question. Explain with a neat sketch working of a diesel power plant. This is a schematic diagram of a diesel power plant. You can see the head of the diesel power plant is a diesel engine. In this you can see the compressor is there to supply the compressed air. Say fuel tank is there or oil tank is there to supply filtered oil to the fuel through the fuel injector into the diesel engine. There will be a lubricating system for a diesel engine working. There must be friction will be there. To reduce the friction, there must be a lubricant system is there. Also, there must be a cooling system. The temperature of the engine increases. We have to reduce it in the proper manner so that to increase the efficiency. So cooling must be done. So there must be a cooling system, fuel system, lubricating system, and this after burning the fuel, the exhaust goes through the silencer. The engine crankshaft is connected to a generator. It will run the generator and it will be producing the electricity. These are the major parts that shown in the figure. Diesel engine. This is the head of the power plant. It is like a big powerful car engine. Diesel fuel is injected into the engine and it is burns the fuel to create power. Fuel tank. The diesel fuel is stored in a tank nearby. The engine draws the fuel from here to run. Air intake. Just like you breathe, the engine needs air to work. It sucks in air through an intake system. Exhaust system. After burning fuel, the engine releases exhaust gases. A system called an exhaust pipe takes these gases out safely. Generator. This is a part that actually makes electricity. It is connected to the engine. When the engine turns, it makes the generator spin, producing electricity. Cooling system. Engines can get very hot, so they need a cooling system like a car radiator. Water or coolant circulate to keep the engine from overheating. Control panel. People can control and monitor the power plant from here. They can start or stop the engine and check how much electricity it is making. The working of a diesel power plant. Fuel combustion. Diesel fuel is injected into the engine cylinders. The engine compresses the air in each cylinder and when the air is superhot from compression, diesel fuel is injected. This causes an explosion pushing a piston down. The motion is what powers the engine. Mechanical energy. Due to this fuel combustion, the mechanical energy is produced. Engine piston move up and down, creating mechanical energy. The crankshaft turn start rotating. This mechanical energy is used to turn the generator, because the engine is coupled to the generator. Whenever the engine crankshaft run, it will be turn the generator. Next is electricity generation. As the generator spins, it produces electricity. It works like a big magnet inside a coil of fire, creating an electrical current. Fourth, voltage regulation. The control panel monitors the voltage, electricity power, and make sure it is at the right level for use. Last stage is distribution. The electricity is sent to places that need it, like homes, schools, factories, through the power lines. Next question. With a neat sketch, explain the working of a hydroelectric power plant. In the hydroelectric power plant, there must be a reservoir to store the water. A large amount of water is stored in the reservoir. From this reservoir, the water is supplied to the turbine through the pipeline. The large diameter pipeline, that is called the penstock, and there will be a gate valve for supplying the water, and there is a inlet valve before the hydraulic turbine to maintain the flow of water to the turbine. So, due to the closing of the inlet valve, there will be sudden rise in the pressure in the penstock that may cause the water horn effect and may be bursting the pipe. To prevent this, a surge tank is provided in the penstock. When the inlet valve is open, the hydraulic turbine will be run and turns, and it is connected to electric generator, and it will be producing electricity, and it will be distributed through the power lines through transformer. The main parts are dam, intake structure, penstock, turbine, generator, transformer, transmission line, and tail race. Dam, it creates a reservoir to store water and control its flow. The height of the dam determines the potential energy available. Intake structure, water is collected from the reservoir and directed towards the turbine. Penstock, a large pipe or conduit that carries the water from the intake to the turbine, where the water's kinetic energy is converted into mechanical energy. Turbine, water from the penstock strike the turbine blades, causing them to spin. Generator, the spinning turbine is connected to generator, which converts the mechanical energy into electrical energy. Transformer, the generator electricity is stepped up in a voltage through transformers for efficient long distance transmission. Transmission line, the electricity is transmitted through high voltage lines to homes and industries. Tail race, after passing through the turbine, the water is released into the river or tail race channel. Working of hydroelectric power plant. Water from a reservoir is released and flows through the penstock under the influence of gravity. The high speed water strike the turbine blades, causing them to rotate. The rotating turbine is connected to the generator rotor, which induces an electromagnetic field in the stator coils of the generator. This interaction generates electricity through the principles of electromagnetic induction. The generated electricity is then sent to the grid for distribution and use. Compare liquid and gaseous fuels. Here you can see the table indicate the merits and demerits of the solid fuel, liquid fuel, and gaseous fuel. In this question, it is to compare the liquid and the gaseous fuel. The merits of liquid fuels are high energy density, easy to ignite, relatively clean, burning, can be easily transported. The demerits are flammable and explosive, difficult to store and handle, produce harmful emissions. In the case of gaseous fuel, the merits are clean burning, easy to ignite, relatively safe to handle and store, can be easily transported. Demerits are low energy density, expensive, difficult to distribute, can be odorless and colorless, making leaks difficult to detect. Next question. Describe the working of Jenger's gas calorimeter with a suitable sketch. Jenger's gas calorimeter is used to find out the calorific value of gaseous fuel. Here it consists of a gas meter to measure the metered quantity of fuel, gaseous fuel, which is supplying to the chamber. There is a pressure regulator. Also, there is a water supplying unit will be there. The cold water is supplying. The normal cold water is supplying to the chamber. The inlet water temperature is measured using a thermometer, and outlet water temperature is measured using another thermometer. And it is the quantity of water is flowing that is also measured. Here you can see after burning, the gas is burning and the gas will be gone out. That also measured using a thermometer. You can see here some condensate will be. Actually, what happens in this case is to measure the calorific value of a gaseous fuel, the gas will be burned inside the chamber. So it will be burned due to burning, it will be producing some heat energy. So whenever water is circulating through this surrounding of this chamber, the water is absorbing the energy of this heat energy of the fuel. And by calculating the energy absorbed by the water, we can find out the calorific value of the fuel that are equal. The energy produced by this gaseous fuel by burning of the gaseous fuel, and that will be absorbing by the water. So the energy exchange will be equal. That is used to find out find the calorific value of the fuel. The working of the Jenger's gas calorimeter. Burning of the gas to be tested is burned in a combustion chamber. Heating the water. The heat from the burning gas heat the water in the water jacket. Measuring the thermometer recorded the water temperature before and after it gets heated. There is a thermometer inlet and there is a thermometer outlet to measure the temperature of the water. Calculating the difference in water temperature helps us to calculate the energy content of gas. To find out the calorific value of the gas, we can use the simple formula. Calorific value of the fuel, gaseous fuel, is equal to volume of water into temperature rise, that is a change in temperature, into 4.18 by gas volume. That will give the calorific value of the fuel. Next question. List the advantages and disadvantages of diesel power plant. Advantages of diesel power plants are high efficiency. Diesel engines are some of the most efficient engines available, converting up to 40% of the energy in the fuel into electricity. Reliability. Diesel engines are also very reliable and can operate for a long period of time without needing maintenance. Versatility. Diesel power plants can be used to generate electricity in a variety of locations, including remote areas where there is no access to the other source of energy. So we can transport diesel engine to one place to another place. So the remote areas we can produce electricity using a diesel power plant. Disadvantages of diesel power plant. Even though some advantages, there is also some disadvantages. Air pollution, that is one of the major disadvantages of diesel engine or diesel power plant. Diesel engines emit a number of pollutants including nitrogen oxide, sulfur oxides and particulate matter. These pollutants can cause respiratory problems and other health problems. Second disadvantage is noise pollution. Diesel engines can be noisy, especially when they are first started or when they are under loading condition. Cost diesel fuel is more expensive than other sources of energy such as natural gas or coal. Next question. Explain nuclear fission, fusion, and chain reaction. How fusion reactions are controlled in a nuclear reactor. Nuclear fission. Nuclear fission can be defined as the process in which a nucleus is split into two divisions, more or less of equal mass, releasing energy in the form of heat. When uranium 235 atom is bombarded with a neutron, it is split into two lighter nuclei, barium and krypton, and also producing large amount of energy. Nuclear fusion, the process by which two light atomic nuclei combine to form a single heavier one while releasing massive amount of energy, is called nuclear fusion. Here you can see the pictures of the nuclear fission and fusion. Here you can see a nucleus is a heavier nucleus is bombarded with a neutron. It is split into two lighter nuclei and also is producing many number of neutrons and large amount of energy. The case of nuclear fusion, you can see lighter nuclei like deuterium and tritium. It will be combined to form a heavier nuclei helium and also releasing energy. You can see in the case of nuclear fusion. Chain reaction, a chemical or nuclear reaction where a neutron causes fission, ejecting secondary neutrons, which in turn induce other nuclei to split, continuing until the fissionable material is consumed and producing a tremendous amount of energy, is called nuclear chain reaction. A nuclear reactor is a device used to initiate a nuclear fission chain reaction and control it with appropriate amount of energy release. It uses a fuel, a radioactive isotope, normally in the form of rhodes, which undergoes nuclear fission. Fuel. Nuclear fuels usually used in the reactor are isotopes of uranium and plutonium. Isotopes like U-233, U-235, plutonium 239 can be fissioned by neutrons of all energies. Fuel is arranged as fuel rods in the form of fuel rods. Moderator is used to slow down the kinetic energy of fast moving neutron. It is because only slow moving neutrons maintain the fission chain reaction. Substances like heavy light water, heavy water, carbon, beryllium are used as moderator. Control rods. Control rods are used to control the nuclear chain reaction. Control rods control the chain reaction by absorbing neutrons. Control rods are usually made up of cadmium and boron. Next question. Explain the working of boiling water reactor with a suitable sketch. We can see the sketch of a boiling water reactor, BWR. Sometimes it is asked like a BWR short form. Boiling water reactor. You can see at the center core the nuclear fuel is settled. Uranium fuel, you can see the nuclear fission will be occurring and tremendous amount of heat energy is producing from this center core. This heat energy will be transferred to the coolant, cooling water. You can see the water is there, it is circulating over the uh, surrounding the reactor core. So this water will be absorbing heat energy produced from the reactor core and it will be start boiling and it converted into steam. So this steam will be supplied to the turbine. So the high pressure steam turns the turbine blades, and the condensate will be, that is the output of the turbine, that is the steam at a low pressure, pass through the condenser, and it will be again converted to liquid state, and through the feed pump it is again supplied to the reactor. So again it again start boiling, and again it becomes steam, again pass through the turbine, again condense, again it is in the form of water, again this will be circulated. Circulation will take place. This cycle will be repeated. So the turbine is coupled to a generator, and it will be start rotating the generator, and it will be producing the electricity. That is the working of boiling water reactor. There is chance of radioactive material may be get transferred to the blades of the turbine, because there is a direct contact will be. Any leakage will be from the reactor core. It may be goes to radioactive material to transfer through the steam and the water. The working of boiling water reactor (BWR). In boiling water reactor, the coolant water absorbs heat produced during the fission reaction in the reactor. The fuel used is enriched uranium oxide. Water evaporates and steam is generated in the reactor itself. In this type of reactor, there is no need of separate boiler, because the boiling takes place from the reactor itself. So there is no need of separate boiler is not required. In BWR, the coolant is in direct contact with the turbine. So if a fuel rod has a leak, radioactive material could be placed on the turbine. That is a risk in this case. Next question. Write short notes on uranium, thorium, and plutonium. These are the fuel materials used in the case of nuclear reactor. Most common fuel material used in nuclear power plant is uranium. Uranium is a naturally occurring element that is found in earth crust. It is mined and then enriched to increase the concentration of the fissile isotope U-235, uranium-235. Uranium-235 is fissionable, which means that it can be split by neutron to release large amount of energy. Other fuel materials that can be used in nuclear power plant include plutonium and thorium. Plutonium is a man-made element that is created when uranium-238 absorbs neutron. That means it is produced from the fast breeder reaction. Thorium is naturally occurring element that can be converted into fissile uranium-233. Other fuel materials that can be used in nuclear power plant includes plutonium and thorium. Plutonium is a man-made element that is created when uranium-238 absorbs neutron. Thorium is a naturally occurring element that can be converted into fissile uranium-233. Next question. Explain the working of a pressurized water reactor (PWR) with a line diagram or a neat sketch. In this case, you can see it is two loops are there. In the case of boiling water reactor, only one loop is there. In this case, two loops are present. So see, this is a reactor. Inside the reactor core, the fissile material will be undergoes a fission reaction, and it will be producing tremendous amount of heat energy. So you can see a pressurized water is supplying to this. High pressure water, nearly 150 atmosphere pressure water is supplying through this system. So the pressure is increasing, the boiling point is also increasing. So it cannot be boiled at 100 degrees Celsius. So it cannot be in this, it will be remains in the state of liquid state. It can circulate through the reactor. So in this case, the heat energy from the reactor is absorbed with the water, and it is pressurized. It cannot become steam, and it will pass through the heat exchanger. When it is passed through the heat exchanger, it is transfer heat to the water which is passing to the next side. So the water at a normal pressure becomes state of steam, and it is supplied to the turbine. To rotate the turbine, and again the low pressure steam comes out, and it is condensed, and again it is pumped, and it is again circulated. You can see the line this for feed water heating. A line you can see by taking the steam from the turbine. It can be used to heat the water. Thus, it is the turbine is coupled to a generator and it can be produce electricity. Pressurized water reactor make use of two loops, primary and secondary loops, to convert heat generated by the fuel into electric power. The primary loop, the pressurizer, maintains a high pressure in water in the range of 150 bar. The pressurized water coolant is circulated in the reactor. Due to this high pressure of water, water does not boil. The coolant gets heated in the reactor and enters the boiler and transferred to heat to the feed water in the boiler in the secondary loop. Feed water evaporates and runs the turbine. The heat exchanger means the boiler. That stage the heat transfer takes place and the water will become steam and it is passed through the turbine. Summarize the causes of greenhouse effect. The greenhouse effect is when certain gases in the atmosphere trap heat from the sun, keeping the earth warm. This is a natural and help support the life. But when we add more of these gases through activities like burning fossil fuel, it traps even more heat, leading to global warming. Burning of fossil fuels like coal, oil, and gas. Combustion of coal, oil, and natural gas for transportation, electricity, and industry release large amount of carbon dioxide and sulfur dioxide. Deforestation and land use. It is also causing greenhouse effect. Cutting down and burning trees reduces the number of plants that absorb carbon dioxide from the atmosphere. Agriculture practices, especially rice and cattle farming, fertilizers, animal manure containing nitrogen cause nitrous oxide, which adds to the greenhouse effect. Industrial process, cement production, etc. Factory release greenhouse gases as byproducts of various manufacturing process. Waste decomposition. Organic waste in landfills decompose without oxygen, producing methane that also increases the greenhouse effect. This methane is a greenhouse gas. Describe the safety measures followed in power plants. First one is the management commitment. The top management of the power plant must be committed to safety. This commitment must be communicated to all employees and must be reflected in the plant's policies and procedures. Employee training. All employees must be properly trained in safety procedures. This training should be ongoing and should be tailored to the specific job duties of each employee. Equipment maintenance. All equipment must be properly maintained to ensure that it is in safe working condition. This includes regular inspections, repair, and replacement. Emergency procedures. All employees must be familiar with the plant's emergency procedures. These procedures should be tested regularly to ensure that they are effective. Communication. There must be a clear communication between all employees about safety risks and procedures. This communication should be ongoing and should be two-way. Incident investigation. All incidents must be investigated to identify root causes and to prevent reoccurrence. Continuous improvement. The last point is continuous improvement. The safety policy should be constantly reviewed and improved. This is important to ensure that the policy remains effective as the plan changes and as a new hazard are identified. Okay, thank you.